Hey guys, just wanted to go over some constructions with you before you take the test, because these are definitely some things that you might need to know. So I know that we've gone through some of these before, so if you need to fast forward, go ahead and fast forward through some of these. The first one that we want to do is to construct a square with the given side length. And again, I just want to highlight this right here, compass and straight edge move. So anytime that it says construct or compass and straight edge moves, or both of those, it means that you're going to have to use circles first. And once you have those intersecting circles, then you can add in those straight lines. Okay, so none of these constructions are going to happen unless you have those intersecting circles. So the very first thing that we want to do when we're constructing a square is we actually want to turn this segment into a line. And really a square is just a shape that has all perpendicular sides. So we just need to create perpendicular lines through these 2 points right here. So if you're creating a perpendicular line through a point that's on the line, that's the eyeball construction. So if you just create a circle at F and make it go to C, you're just creating another circle that goes back across, because what you're doing is you're wanting to bisect this segment right here. So I'm just going to take a segment this time, and I'm going to create this one right here. But now from F to C, we also know about squares is that all 4 of their sides are congruent. So if I have this side right here and this side right here, those 2 are not congruent. But if you look at, I'm going to change the color on this here really quick. If you look at this circle, okay, this distance from F to C is 1 radius of the circle. And we talked earlier in our review today that there are infinite number of radii in any circle. And so all of those radii have the same length. So the place where I need to put the point to get this other side is right here. So now I have 3 of my 4 points that are going to make up the square. I just have to figure out where that last one is going to be. So I am just going to hide some of these circles here so that it doesn't get so overwhelming, because I know sometimes there's a lot of stuff going on here. And I'm actually going to get rid of some of these points as well. Okay, so we have this line here perpendicular to this line here, but for a square we need this side here and we need it to be perpendicular also. So we're basically just going to create that same construction again, but in this case we're going to go from C. So eyeball construction again, put your segment in there, and then again I'm going to put this, highlight this in a different color here. Okay, you can see this distance here is a radius, so we need to find another radius of that circle, and so we're going to put a point right here. And now that we have that, we can use our polygon tool and we can go 1, 2, 3, 4, and there is, maybe, there's our square. Maybe. There we go. And I don't have the angle measure tool on this one, but if we did, you could see that those would all be 90-degree angles. Second one that we're going to do is construct the angle bisector. This one's really similar to a perpendicular bisector. Again, we want our bisector to go through point A, so we need to create a point centered at A. And when we do that, we want to put the other point on the side of this angle. And if you notice, this circle also intersects the other side here. So we're going to have this segment right here and this segment right here. And these 2 new points that we have, B and E, those are going to become the centers for 2 new circles. So we're going to start at E and work our way back to A, and start at B and work our way back to A. And where those 2 intersect becomes our angle bisector. All right, the next one that we're going to look at, find a location that is equidistant from all 3 vertices using compass and straight edge moves. So if you think about this, find a location that is equidistant. Well, we found locations that are equidistant from 2 points before. So if we find a location here, anything on this line is going to be exactly the same distance from A as it is from B. Okay. So let's do the same thing with a different side. Let's find out where this perpendicular bisector is. There we go. Now, you can see where these two lines intersect right here. And I'm going to show you how you know that it's equidistant from all three vertices. If you take your circle tool, put it at that point where those bisectors meet, and you draw your circle out, it should go through A, B, and E. So that circle is inscribing that triangle. The next one is to construct an equilateral triangle inscribed in the circle. So all we want to do is we want to put a point, just one point randomly on that circle, and that's going to become the center for another circle. And so we're just going to go from that point back to the center, and then each one of those intersection points around the circle is going to become another center. So we have circle, circle, and we're just going to keep going all the way around till we have all the intersection points labeled. And what we're trying to do is draw an equilateral triangle that's inscribed in the circle. And so an equilateral triangle means all the sides are the same length, and inscribed means that all of the vertices touch the outside edge of the circle. So now you can see that we have this circle that goes through every single point of that triangle. Okay, the next one is similar to the previous one. Again, we're going to start with a circle, and if you want to, you can change this circle into a different color. Sometimes that's a little bit helpful. And what we're going to do is just put a point on that circle anywhere. Oh, we already have B, so we'll just use B. So we're going to go from B to A, and then find another intersection point, go back to A, new intersection point, go back to A, new intersection point, go back to A, new intersection point, go back to A, and we have this intersection point over here. So a hexagon is just connecting all 6 points in the correct order, and you can see that a hexagon is a 6-sided shape, and there's our hexagon right there. Okay, construct an equilateral triangle using compass and straight edge moves. So we've already demonstrated one way that we can make an equilateral triangle, and that was with all the circles. There is another way that we can do an equilateral triangle, and that is just with 2 circles. So wherever those 2 circles intersect, we have those 2 centers right here. We have the third point where they intersect, and then you can draw the triangle there. So you can do an equilateral triangle in more than one way. The next one is construct the perpendicular bisector. So again, we're just center at A, radius AB, center at B, radius AB, and then where those 2 circles intersect is where we would put our line. Perpendicular bisector. So remember, the distance from B to the perpendicular bisector would be the same as the distance from A to the perpendicular bisector. From C to D, when these 2 lines intersect, those would be 90-degree angles in here. Okay, construct a line perpendicular to the given line through point B. That is going to be that eyeball construction again. So again, we're saying we see the word construct, we see the word compass and straight edge moves. So you can't just draw the line. You have to make sure that you are using circles. And it does not matter how big your circle is, but you just want to make your little eyeball. Oops, that one's not a very good one. Here we go. So we're going to go from this side to C, and then from C back to D. And now we can see where those 2 circles intersect, and that is going to be our perpendicular line. This one's a little bit different because we're still constructing a perpendicular line, but now the point is not on the line, it's off the line. So all we have to do with this one is just make 2 points, and we just have to make sure that they're on opposite sides of C, and then use those as centers and have them connect at C. now we have a line perpendicular to this existing line. Okay, the next one is to construct a line parallel to the given line through point C. So remember, this is just a series of perpendicular lines. So the first thing that we want to do is we want to create a perpendicular line through C, and that first step is just like this step right here. So we're going to pick 2 points that are on that line, and it doesn't matter where they are as long as they're on opposite sides of that point, and then use those as centers to go and create 2 circles, and where those intersect is going to tell us where that perpendicular line is. And so then the next thing that we need to do, we're trying to go through C, so I'm going to hide some of these circles so that there's not so many of them. Because we want our line to go through C. So I have this line and this line are perpendicular, and so now I need to make another line perpendicular to this one. And this is the eyeball construction. So when the point is on the line, we use the eyeball construction. When it's off the line, we pick our 2 points and construct circles back to that existing point. And remember, it does not matter how big your circle is, but once you get that circle, you're just going back across with your circles. And then there's our parallel line. Okay, the last one is constructing a square inscribed in the given circle. So the very first thing that we want to do is we want to create a line through the center of the circle. And where that line intersects is going to be 2 corners of our square. So G and H are going to be 2 corners of our square. Now, we talked a little bit about it the other day. We didn't have a huge discussion, but we talked about how this segment is the diameter of the square. And in order to find the other diameter of the square, we need to bisect this segment from G to H, because the diagonals of a square bisect each other and they're perpendicular. So they're the perpendicular bisectors of each other. So this is basically just the eyeball construction. You're creating your 2 circles, you're drawing your line through those intersection points, and once you have those 2 intersection points, now you can see where those lines cross the circle, and those are the 4 corners of our square. There we go. Let me know if you have questions. Please don't wait until Friday to ask them. Email, remind, whatever you need.